Okay, welcome back, SL2. We're almost finished solving this proving it. So I'm pretty excited that we're almost done. This was a lot of work here. So if we look at the last step here is to go back to cosine theta equals AC over AD and take a look at our diagram. Our AC is equal to AB plus BC. And we know that AB is 1. So let's start there and let's start substituting some items in there. So let's first write it out, where we have AC is equal to AB plus BC. Then we know that AB is equal to 1, and we also said that BC is equal to cosine 2 theta, and AD we said was equal to 2 cosine theta. And this whole item, 1 plus cosine 2 theta, is being divided by 2 times cosine theta. And all this, again, is equal to cosine theta. Alright, so let's go back up and look what we're solving for. And we're trying to get our cosine 2 theta by itself and 2 cosine square theta minus 1. Okay, so think about how we're going to do that. We're trying to get cosine 2 theta by itself. So my first step is I'm going to have to, we talked about rational expressions the other day, and the only way to isolate this is first to multiply both sides by 2 cosine theta. So let's go ahead and do that. And if we have it here, ran out of room here, but I think you know what I'm doing here. So let's say that I wrote that all the way through, would be 2 cosine theta. That would cancel here. And then 2 cosine theta times cosine theta would be 2 cosine squared theta. And we're still trying to isolate cosine 2 theta, so one last step, we'll subtract both sides by 1. Okay, so if we subtract both sides by 1, we'll end up with cosine 2 theta equals 2 cosine squared theta minus 1. Okay, so that's the end of that proof. Nice job. Pat yourself on the back. We have 2 more things to go over about triangles. Okay, so the last part of our triangle review is to just kind of go over the basics. Anytime you see a triangle, if you see a right triangle, go ahead and use that Pythagorean theorem that we've talked about a lot today. A squared plus b squared is equal to c squared. Also, you can use your trig functions of SOHCAHTOA when there's a right triangle. So remember that sine is equal to the opposite over hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. But when you don't have right triangles, you need to make sure you use either the cosine rule or the sine rule. If you have 3 sides, you know those sides, or if you have 2 sides and an angle, then you go ahead and use the cosine rule. The 2 formulas I want you to really understand are the ones that are on your formula sheet when you come to the IB exam in May. You probably last year solved all of these and had them set up for every angle. But these are the 2 they have it solved for c squared and for cosine c. So I want you to make sure that every time you're looking at the IB set up the IB formula sheet, and then you go from there with any problem. So these are the two that we're always going to reference. In our first example here, we have triangle ABC, where the side length A is equal to 8, the side length C is 7, and angle B is 131 degrees. They want us to find B and C. So always your first step is to go ahead and set up your unknown so you know what you're finding. Here, my angle B is 131. They give you the angle in degrees, so you want to make sure that your calculator is in degree mode, because you'll be wanting to be given the same answer for C in degrees. So the way the IB exam is written is if they give you the degree in radians, you want to give the answer in radians. If they give it to you in degrees, you want to give the answer in degrees. So the first thing was setting up what B is, and now remember our side length of A would be the opposite of our angle A. So this side would be 8, and then the opposite of C would be our side length C, so that would be 7. Okay? So this side length would be the opposite of B, so that would be our unknown of B. It's really important to understand that setup. So if you need to, go ahead and pause the video and make sure you understand what we just did. If you're fine, we'll keep moving, and we're going to be looking at this formula first. I want to solve for B. So I'm going to go ahead and write this formula in relationship to B, and I'm remembering back from last year that I know that I can rewrite this as B squared equals A squared plus C squared minus 2 times A, and then I can change this out for C and change this out for cosine B. So I'm going to go ahead and start and write that like that. This formula is so complicated, it's a good idea to write that all out just to make sure you substitute everything in. So our side length A is 8, so I'm going to go ahead and do 8 squared, which would be 64. Our side length C is 7, so I'm going to go ahead and do 7 squared, which would be 49. And then this part I'm going to go ahead and plug in. So 2 times our A again is 8, and our C again is 7, and then cosine of 131. So on paper 1, where we can't use our calculator, we'll only get to 30, 60, 90, 45, possibly a 180, but typically it's our 30, 60, 45, and 90 or 0 degrees. That every other time this kind of problem with a cosine of another angle that I didn't mention of our special triangles, we'll be able to use our calculator. So go ahead and evaluate and plug this into your calculator. Make sure you're in degree mode. Do 2 times 8 times 7 times cosine of 131 degrees. And that should end up being negative 73.48. Okay. So here you notice that you have a minus a negative 73.48. So just remember with algebra that will change to a positive. So we'll have 64 plus 49 plus our 73.48, which will sum up to 186.48. And this is all equal to B squared. So to find B, we will have to take the square root of both sides. It's a good habit to, even though you know that distance is going to be positive, to go ahead and show that you know that, and just take the square root of B squared, show that you know that B could be a plus or minus 13.65, and then show that you know that distance has to be positive, so you put B equals 13, and then IB asked for 3 significant figures, so we'll round up to 13.7, 3 significant digits, and we'll put units. Okay. We still need to find the cosine still need to find angle C, so we're going to use the cosine C formula here. It's already written this way, so we're just going to be plugging in. So go ahead and take a minute and write. Okay, confirm that you plugged in the same way and got 8 squared plus 13.7 squared minus 7 squared divided by 2 times 8 times 3.7. And it's just good practice to simplify as much as you can. Some of this problem we probably will have your calculator, but it's just good habit to write out the steps in case you make a math error. And we'll find our cosine of C would be equal to 0.92468. So to find our angle C, we have to take the inverse cosine, and we'll get C to equal 22.4 degrees. Okay, so our last problem, when we have 2 angles and a side, we're going to use the sine rule. Depending on your problem, you could use either one, but it will depend on what is the given. In our case, for our example 2 here, we're going to be given 2 angles and a side, so we'll have to use the sine rule. Remembering what the sine rule is, it's A over sine A equals B over sine B equals C over sine C. And also remembering how that relationship works, remember that the side of A will be opposite that angle A. Our side of C will be opposite that angle C. And our side of B will be opposite of our angle B. Okay, so make sure you take the time to set up your significant figures. Our A is given as 45, our angle of A is 97 degrees, and our angle of B is 24 degrees. So again, in this problem, we're going to be using our degree mode on our calculator. Okay, so the first part is probably fastest, is to find what our C is, and we'll use our knowledge of triangles where every angle would have to add up to 180 inside our triangle. So we'll subtract 97 and 24 from 180 to get C, and we'll get C is equal to 59 degrees. Then we'll use our relationship of A over sine of A equals B over sine B, and we'll plug in 45 over sine of 97 and B over sine of 24. From here, I'm going to really stress that you use cross multiplication to isolate your B, then divide by what you need to isolate B. So first with cross multiplication, we'll have B sine 97 equals 45 times sine 24. Then we try to get B by itself, so we divide both sides by sine 97. Now we'll cancel, and then this is when you want to plug in the calculator here. So you'll have 45 times sine 24 divided by sine 97. And you'll get that B is equal to 18.4 units. Okay, so the last item we need to find is our C. So I went ahead and stopped the video and just go ahead and wrote that out. Same setup as I did here. Again, cross multiplication, you can only cross multiply when you have an equal sign. And before I plugged in the calculator, this item I wanted to isolate C. So our C would be equal to 38.9 units. Thanks so much for working so hard. Have a great night.